Okay. In previous session, we had covered theoretical part on abstraction in Java, and there are two types of abstraction. What is this abstract class and interface? Interface is 100% abstract class, and abstract class is 0 to 100%, which means we can have partial abstraction. So let's do hands-on step by step. First, start with the interface. Now, how do you create interface? Let's see first. Now, go here and create new. There you could see the option of creating class, enumeration, interface, package. So you have to choose the interface option and just give interface is my interface. Anything you can be. Now finish. Could see this. This is public and interface is a keyword and interface name. And you see this abstract, right? You see that? Then you do not have error. As we discussed in the previous session on theoretical part, by default, this interface is the abstract, 100% abstract. All the methods inside interface are by default public and abstract. If you don't override, if you don't mention that, the compiler will automatically gives you this public abstract. So writing this abstract is again redundant. You no need to write about that. Okay, just similarly that, for example, write void make call. Okay, this make call, as you could see, as you don't have access modifier and you don't have abstract keyword, and you just see return type and the method name and the parameter list. That's all. As we know, right, as we discussed that 100% abstract, right, the interface is 100% abstract in the sense, right, as we see it is abstract. The moment it says abstract, all the methods inside this interface are by default public abstract and followed that user defined method. You don't need to write that. See, even if you declare the method like this, how it will be read by the compiler public abstract. Could see the compiler will read like this public abstract. You see, you don't have an error, which means that if you declare the method void make call, means that precedence that before this, right, the compiler will look at this is public abstract void make call. Writing this public abstract is again redundant. You don't need to write that, as it is 100% abstract, and by default all the methods in interface are public abstract, so you don't need to write this one. Okay, similarly write one more method, receive call. Okay, let's have these two methods in interface. Okay, then we will implement those interface in our class. As we discussed, right, an interface can extend interface but and cannot implement interface. If you try to implement some interface, okay, let's create one interface and see that. Now one interface, okay, employee interface. Okay, let's now I have employee interface void list employees. Okay, let's assume we have one method here in this interface. So what we thought that the interface cannot implement interface. Okay, now try to implement this. See, even it is not coming. Implements, right? See, you don't have any option. You forcefully implement that. You see what exception you see. Thus, implement is not at all applicable. Syntax error, right? It is extend, right? It is expecting extend only. Means an interface can extend interface but cannot implement interface. You can see now extend. You can extend this employee. Now, what happens if you extend this my interface, extend employee interface? What did happen now? The method or methods, all the methods in this employee interface will inherit here. Means it is again inheritance concept. If you have an interface object, right, with the help of implementation class, all the methods in this employee interface also will be accessible. Also, you have to implement those methods. Right now, we remove this one and see step by step what happens and how it out. Now, what we discuss here, this interface does not have any method body. It's just a method declaration. This is called as a method declaration. Means it does not, we are not going to provide any body here, right? You see this, if I try to provide any body, right? Now you could see the exception will come. What happens is here, chain abstract method do not specify a body. As right, there is no abstract, but I told you right, this by default is a abstract. All the methods inside interface are abstract. That is the reason the compiler is saying that abstract methods do not specify a body, which means you cannot provide body to the abstract method. Then who will provide this body to this method? The class which implement this interface will provide that body. Now let's take our class, right? My interface implementation. That is how to create a class for this. My interface implement class. Now what happened? What do you do now? You have a class. To implement that, we have a keyword to implement. Implementing sense that providing a body. Which interface you are going to implement? My interface. Just say my interface. The moment you say implement interface, then you could see the compilation error immediately. What is that? You are implementing means you are going to provide a body for this. However, when you say implement, you must have to provide some default implementation. It says this, the type my interface implement must implement the inherited abstract method receive call. Not only receive call, there are another method. So if you say add unimplemented method, then you can see this provide default implementation. So then you can go ahead with your implementation. Make call. Then see here also, you'll have some block of code in your method according to your requirement. Receive call. Now this is how you can provide implementation to your interface. At least you have some dummy implementation. Make sure without implementing all this method you cannot proceed. Let's see now what happens. Now I remove this method. This is still, see this one again, one more method. What it is saying, there is a receive call which is there in interface, but you have not implemented. Similarly, same thing happens. Again, this time you could see make call is not implemented. You could see this one, make call is not yet implemented, which means all the methods that are declared in interface must be implemented. Without implement this interface, right? Without providing implementation, you cannot proceed. Make sure all the methods has to provide body in your implementation class. Otherwise, if you want to make this as abstracted, then we can do that. We will see that in the next abstract class. Now, what is this now? How you call these methods, interface methods? See, you have to create an object, right? How to create an object, right? This is already class which implements the interface. With the help of this class, you can create. So there are two ways you can create, right? By giving a reference to the interface, or we can directly create an object to the from the implementation class. Let's see that. First, create a main method, public static void main. Okay, now the object obj equals to new. Okay, see that. Now the moment you create an object, all the methods in this class are directly accessible, right? See object dot, you could see make call, receive call. This way you can call all those methods. Obj dot receive call, right? If you run this, then you could see the output of these two, make call, receive call. Now you can also create an object using giving the reference to this interface like this. Say this is an, as told you, right, sir, you told that we cannot create object to the interface. Yes, but still I have not created object to the interface. I create object new, the moment to say new keyword is used our implementation class, right? I create object with the help of implementation class and give the reference to the interface. Why you want to give if we have option to, right? If we are able to call the methods with the direct of this implementation, why you are giving a reference to the interface? particular interface? That is the valid question. This interview question also. Suppose in case if you implement multiple interfaces and employee interface, right? See, now you have to provide implementation to that. Now say list all employees, right? Now what you do now, I will give access to call only the methods that are declared in interface to some user, and another guy I will give access to access the methods inside this interface. That case, how you achieve that? Then I will give the reference of this one, obj make call. Now let's create one more object the same way, and obj1 object 1, and give the reference to this guy here. Okay, obj1. Now what happens? See here, obj1 dot, what you could see this one. Have you seen this method? Make call, receive call? No, only list employees, which means you can hide that methods from one interface to another interface. We can control by calling, we can control the method calling of the particular interfaces with the help of this interface reference. Otherwise, if you want to give full access to this interface methods, right, you can go with the implementation class object. So this is more secure. You can protect your interface methods, because sometimes certain scenarios in some use cases we don't want to give full access to access all the methods from all the interfaces. That case you can go by this. Now similarly, if you say obj dot, you could see only receive call and make call. You cannot see list all employees. See here, you cannot see this list employees. There is another way. If your interface object, this my interface wants to access this employee list employee, then how you do that? Instead of extending implementing multiple interfaces, as we seen right purely, you can extend this employee interface. That guess what you do, the method, right, all the methods in this employee interface will access here, which means here we have two methods and here one method. Then you could see here we have implemented all the methods. See, just by implementing this interface, in the sense what, it is extended this interface also, right? Then that case you have all the three methods. Now you try this obj, what it happens, obj dot, you could see list employees. See, this is massive. What the magic here is this, your interface, you have implemented only one interface, but this guy already extended another interface, so this guy have access to this method also. That is the reason you are able to access using this interface reference, you are able to access this list employees. But this cannot be reverse way. Again, if you say obj1 dot, right, if you same make call, you cannot, because this employee interface is not extended this interface. Whoever is extended, then that have access to those parent methods. It is like our inheritance concept, polymorphism. If you extend a parent, right, all the parent behavior is there in the child, but not the child behavior to the parent. This is exactly applicable here also. So this is how you can call this implement interfaces. Okay, hope you are clear about this, implementing the interface, extending the interfaces. Okay, now this is all about the interface. And one more thing here, right, as told you, interface can have constant variables that's called as a final. You can see this public, abstract, final, string. Now if you want some variable that cannot be changed, then you can have this one, right? All the default methods, you see this one, remove invalid modifier. What is that? You cannot have public, abstract, final. Why? Because abstract in the sense it is incomplete and final is not, so you have to remove this one. All the variables that are declared in the interface should be public final. Why do we need this one, right? Anyway, if you are implementing a particular interface, if you are implementing an interface, then if you want to access those variables as just like that without changing, then you can declare all this. So in interface, mostly we are declaring all our constants. This in our implementation class, you can call, right, call that obj dot, you can call this, right, string, right. You can print this one, you see how this it comes or not. Okay. Syswalk. Okay. Now run this and see, you can access those values. See Java, which means these are one-time installation, one-time declaration and installation values. If you want to use across in your application, right, with the help of this interface object, you can directly access that. You don't need to create an object to this, right? If you want to call these variables, it is not only where you can with the help of interface directly, right, you can access that variables. How is that? You see this one, interface dot c string, right? You can directly call the variables with the help of interface name. You so this is actual way how we have to access the variables in declared in the interface. You no need to create an object. Why you want to create an object? Right now, if you have in your class implement this interface, that's why you have the option to create object. Suppose if your class does not implement this interface, right, then how do you access this? You cannot, right? First, let's see, for example, now I'm removing this one, everything I remove this, okay? Okay, I remove everything from here. Now you want to access the variable that is declared in this interface. How you do that? Directly interface name dot variable name. Then you can call that. So wherever you want, whenever you want to access those variables, you can directly use the interface and dot variable name. So this is what the magic of this interface, and how you can use that variables declared in the interfaces. That's all about our interface. Okay. Just say that again. Once again, we recap this. If we have missed anything, we have not created an object to interface, right? We create an object, but it is indirect way of creating an object. Means what is indirect here is this: our implementation class provide an object for you. Implementation class creating the object for you and giving the reference. We are not directly creating object. In terms, we can simply say interface cannot have object instantiation, right? And also constructor, right? You when if you try to put some constructor here, right, you could see the compilation error. First of all, it is abstract, right? First it is there, then how do you expect a constructor? You cannot. And just see that. So if you are going that constructor is the same as our class name, it contains some method, right? Some default method, some default body here. In as interface, you never have any method implementation. See, interfaces cannot have constructors. You could say the direct error. So that is the reason will not have any constructors in the interface. Okay, this is all about interface. Now jump back to abstract class. Now what is abstract class we discussed, right? Let's create one abstract class. Okay, just remove all these things. Okay, let's assume we have a class. I have created a abstract class 1. Now this is a normal class. Now we will change this class to abstract. When do you change this abstract? Okay, let's see now. Public void make call. Okay, the moment I declare the abstract method here, what it say, then you could see the compile time error. What is this saying? Hey guy, you say public void make call, you have to put mark me either what I do, I have to be abstract or what it means. Just say abstract, then you could see the error will go off, then it will propagate to the parent. Hey guy, you make me abstract, remove abstract. Either the abstract method may call in type abstract class can only be defined by an abstract class. In the sense what? At least if you have any one method is abstract, then make sure your class should be marked as abstract. Then I will lose this, right? A compile error. I will leave the compile error. You could say this: if you have at least one method as abstract, then class has to be marked as abstract. If a class is marked as abstract, right, you may or may not have an abstract method. You can provide this implementation. That's all. Means you may not have that. But make sure if you just say the syntax is that, then this is expecting as a body or change to abstract. Either you can do either that or this, but you cannot make me like this because this required a body instead of a semicolon. Or if you want to change me as an abstract method, if you are not going to provide implementation. So this is how that abstract keyword works. If you have abstract, if you mark the class as abstract, you may or may not have the abstract methods, but at least one method, if you have at least one method as abstract, then your class must be update or marked as abstract. See that you could see the error is there. So this is how that. Now, as we discussed, the abstract class can have both the abstract and non-abstract method. How is that? You can see public void receive call. So then I will provide this implementation to this guy. Okay, receive calls. This guy, see, good, we could see this. We have one abstract method and one non-abstract method. Then as we discussed that, can we have a constructors? Yes, abstract methods can have a constructors. We know that the syntax of the constructor, the public, same as class name. And you see this declared, okay, abstract parent class constructor. Okay, this is how you do. Now let's see that you try to create an object here. Let's see this. We have a main method, it's already created. Now I am going to create an object to this abstract class. See, I just copy this one. See, abstract class equals to new. You could see, see, no, it's not allowing. Okay, I will forcefully try to create object. You could see the compile time error is there. Okay, sorry, here first you have to write a main method, void main string. Now you see you have a compilation error. Abstract parent class cannot instantiate the type abstract parent class. Why? This is incomplete. Even though you have provided method implementation to one method, you have provided body to one method. However, you have one abstract method still exists. So that is the reason you cannot create object to abstract class. This is how that. So that is why we are saying we cannot create object to abstract class. Then who is going to create that? This is incomplete. Whoever wants to access this, they can provide this. Okay, then okay, this guy is doing this one. It is doing okay, sports bike. Okay, I just remove everything here. Okay, now let's see. I create a sports bike, or just I will change something, a child. Okay, abstract child class. This guy is going to extend that one, which means then he will complete the parent implementation. So what he has to? He has to extend the abstract parent. Okay, now he extend that. The moment he extend that, you can see the compile error. Why? You have one method which is partially, then you have to implement that partial method. See this, all unimplemented methods. You have to first have to provide the implementation, make calls, then you go ahead with that. Here you can have your own methods, no worry, just as it is your own class, right? You can have your own methods, public list employees, then you can have your another methods, right? List all. employees. Like you can have your own n number of methods here, right? The moment to extend abstract class, right? Parent abstract, right? Abstract class, which is a parent, then you have to provide the method implementation to that, and you can have other non-abstract methods. Okay, now let's see whether you can create object here. You can create object outside of this class, no matter wherever you create, it is the same way. Public static void main. Now you try to create, you try to create object to the parent. Okay, as we seen already. Let's see one more time what happens here. Again, it will not allow you to create, right? It doesn't make sense. Again, number of times you do that. Now with the help of child class only, you can create object. Okay, child object equals to new. See, child class object. Okay, now the moment to create, as you say that with the help of child, you are able to create object, but no, you are not using any parent. All right, how that? Just give the reference to this guy. Hey guy, I create an object with new keyword is the child class, right? Abstract child class keyword, right? With the help of child class, an object is created and giving the reference to the parent. Then using this one, you can call all your methods. What methods you have? Make call and receive call. You have two methods here, right? One make call and receive call. And you could see this one. Employee list employees is not part of your method, right? So this, see, you cannot access that one, right? It is same as something like we have implement multiple interfaces, which whichever the reference we give to that particular interface, that those methods can be accessible. This is the same way as that. Suppose if you want to access all the methods that are declared in the parent class as well as in the child class, then you can directly give the reference to parent child class. Then you could see all the methods: list employee, may receive call, make call. This is how you can restrict, you can protect, you can prevent calling all of these methods. You can give restriction to specific methods, certain methods to, right? This is called as abstraction, means we are hiding, we can call it as a method hiding also. This is one way. It is not only the method static method, means method hiding is nothing but even though your class have all the methods, but you are not giving access to all the method that in your class. It might be extended some parent abstract class, or it might be implemented multiple interfaces. So you just give access to specific or particular methods, right? You can hide the rest of the methods, right? Yeah. So this is how we can create object to your abstract class. Now what to do? Just call any one of the method and see this one. The moment you call this one, then first create a constructor here. We missed that, as we have a constructor here for both the classes, and see how this constructors is calling. Okay, this is abstract child class constructor. Now run and see this one. What you could see, abstract parent class constructor gets called, abstract child class gets constructor call. Okay, then the method you are calling this one, as you see this side. And now if you call, give the reference to this guy and say and change make call and run this program, you see that, is there any difference there here? No difference. You still access the constructor of your parent class as well as child class. So this is how you can access the abstract class and create an object to abstract class. Right now, one more point to remember here, as we told, right, an abstract class, right, can have final method. There can be a final methods in the abstract class, but any final methods in the public cannot be declared as final, which means it cannot be public abstract. As I told you, right, in the interface also it cannot be. See, public abstract final, right? If I say final, then this cannot be allowed. You can see error. It's a combination. Abstract method make call and type can only be a set visibility of one of public or protected. You cannot have abstract final. This will not work. So if it is declared abstract, it should be abstract. Then you cannot have abstract and final combination. And one more thing here, if you want this child class also abstract, and if you don't want provide implementation to this guy, then you still leave that one. This, what is this method here? Some make call. No, I don't want to provide implementation. No, how it works here? You just leave that one. Okay, then this again you have to mark as abstract. Then you go ahead with this, you do move, and this guy is saying, hey, please provide unimplemented methods, but you don't want this one. This time I will say abstract, then I mark this class also abstract. Okay, then you could see the compile time error here, but you get the error here because again your child class again it changed as abstract. Then again you cannot create object to this class. Again whoever extended this child class, there you have the option to create object. So this is how you can play with your abstract keywords. This is all about our how abstract works. So there is nothing confusion. You just think that interface is 100% abstraction, where abstract class is the 0 to 100%, which means it is a partial abstraction. So abstraction, first we think about abstraction is what we are hiding the method implementation. What we are doing it here, if you think about the example of this interface, right, just have a functional, right? What this functioning, it will help you to make a call and receive a call, but you don't know what, how it does, how it implement. This guy implement this interfaces, know that. See, this is hiding the actual details, then giving access to only the functionality, right? What it do functionality, but how it does is this guy. You don't want this, what method is provided for you, that how it is provided inside implementation. So that is called as abstraction, means hiding the actual implementation and giving you the essential feature. Means essential feature is nothing but what is required to the end user to access that. That's nothing too much. Okay, it makes sure just keep hands-on, just do practical examples, go ahead, you can explore more and more on that, so that you will get more knowledge on that. Simply listening and living cannot help you. Make sure everyone has to practice on this, and this is one of the most important topic in interview. First they will go, what is an abstraction in Java? First you have to give the clear definition, right? What is that? It is in simple terms, you can say that, right? It is the process of hiding the implementation details from the end user perspective and give only the functionality, or means what it does, that's all. And how it does is the hiding. What it does is a implement functionality you give to the end user. How it does is the hiding part. Okay, there are two ways we can achieve implement this abstraction, right? The first is interface, which is 100% abstract, and second is the abstract class, it is the partial abstraction. Now, how do you say it is a 100% abstract with the interface? All the methods in interface or public abstract, and it never expect you to provide any implementation details. That is why we can say it is 100% abstraction. And in abstract class is partial. How? Why? Because you have concrete and non-concrete methods, which means you have both abstract methods and non-abstract methods. And another difference is that interface does not have a constructor, whereas abstract class can have constructor. But in these two ways, we cannot create object to either abstract class and interface. Okay, that's all. If you have this one, you go through this all the rules that define what is an abstract class and what is the rules, right? If you know the rules properly, then you can play around with that all, right? How it does and what it looks and what it can do. Make sure you have to know the rules, what actually the abstract class and what actually the interface, right? Where we can, when to use interface and when to use abstract class. That's again the interview question. We use interface if you want to achieve 100% abstract class, which means if you want to provide the complete implementation of your own. right? Then you go for the interface. When you go for abstract class, is that if you want to have partial abstraction, or if you want to reusable, means if you want to reuse some part of your code and provide some part of your own implementation, which means like that. Now I have the same method, I will just use that receive call, right? Here make call is there and receive call implementation is there. When I go here child, I just receive call, I'm not going to override this one. However it is there in the parent, right? I will just acquire that and consume that one. If you want to override, you override, that doesn't matter. It is again in inheritance concept. Okay, and here make call, and right here if you want to have a different implementation, then you can go with this abstract class. So that's all about abstract and interfaces. Okay. Okay, next see you in the next video. So I will come up with the next topic.